So today we're going to continue our journey of surface area. And yesterday we focused on pyramids. So today we're going to focus on cones. Turns out that the cone formula is exactly the same as this formula, except the base is known. Instead of the base being a triangle or a square or a hexagon, this time the base is going to be a circle. So instead of B, I can actually put circle information. The key difference between pyramids and prisms that we looked at is there's this concept of slant height. So remember that slant height was down the side or down an edge like that all the way to a midpoint. So today we are going to find the surface area primarily of cone. So let's take a gander at the surface area of a cone. Let's refresh that the previous one we looked at for surface area of a pyramid was this. Base is the base is equal to, try that again. Surface area is equal to the base plus 1/2 PL. Now what we can do though is we know that the area of a base of a circle, or the area of a circle, is pi r squared. And we know the circumference of a circle is 2 pi r. So when I substitute those in, the surface area of a right cone is this, pi r squared plus pi r L. So the two things we need is the radius and the slant height, and we plug and play, and that's it. So let's take a gander at this diagram here. This one's straightforward. Everything's given to me. Here is my radius, and here's my slant height. So remember, all this part right here is sort of a mental exercise, and I'm actually going to cancel some of this concept out because it's much faster if we just use this one formula. So I'm going to cross that out, and we'll put b plus 1/2. Let me try that again. So we're going to use the formula that we just gave to you. Pi r squared plus pi r L is my surface area. So we've identified, that's it. Now all this stuff over here is mental, and sometimes you'll be asked just to find the lateral area. Sometimes you'll be asked just to find the area of the base. But in this case, I have L being 15 and R being 10. So all I do is plug and play. So the surface area is equal to pi times 10 squared plus pi times 10 times 15. 100 pi plus 150 pi. Combine like terms to get 250 pi, and we can calculate using our calculator. 785.4 units, and the units on this one, centimeters squared. Both answers are good. The first answer is if they asked you to write it in terms of pi, and this one is rounded. In this case, I rounded to the nearest tenth. They might ask you to round to the nearest hundredth. All right, so it's much faster just to use the one formula. So please take a moment and do number 2. Go. So here's my R, here's my L, and just to keep it here, I'll put it next to it. R squared plus pi RL. And 103.7 inches squared, approximately. 3, we do not have the slant height, which is located right here along this edge. So what are we going to do? I need to calculate the slant height. So if I were to think about this process step by step, clearly my radius is given to me, and that's a 5. Next, the area of the base, I could calculate that, but I'll do so later. Now the slant height is going to be, I have to use the triangle That is right here. So my radius is a piece of that triangle. The height of the cone is a piece of that triangle, and L is. So I'm going to redraw that over here. So here's 5, here's 12, and my unknown slant height. It's a right cone, so we can assume right there. And here's L. Many of you will notice that using Pythagorean theorem will yield me a Pythagorean triple, and the answer will be 13. So L is 13. Now, again, we just plug the 5 and the 13 into our handy-dandy formula. So the surface area is equal to pi r squared plus pi r L is equal to pi times 5 squared plus pi times 5 times 13. 25 pi plus 65 pi is equal to 90 pi, which is approximately 282.7 centimeters squared. All right, so finding cones are, the surface area of a cone is less complicated than finding the surface area of a pyramid. So let's look at the last page, and composite shapes are when we combine things together. And in this case, so for example, it's like the Washington Monument in Washington, D.C., where we have what's called an obelisk. Notice that this part right here is a prism of some kind. More specifically, it looks like a cube. And up on the top is a pyramid. Now notice, it's not a full pyramid. I mean, it is, but when we're talking surface area, we are only talking about the triangles around, called the lateral area. Because I'm not going to, if I were to paint this object, then I would not paint inside right there, that square. So in other words, the square top of the cube and the square bottom of the pyramid, I would not paint. Now, it's probably sufficient to say that I am going to paint underneath there, because it's talking about surface area, not necessarily about painting. So I am going to find the base that's down there. Okay? So when I start to bring this together, what's my formula look like? Well, if I were to consider the area of the pyramid, or the surface area of the pyramid, it looks like this. B plus PL. And if I consider the surface area of the cube, it's going to be 2B plus PH. What, though, is not going to be considered? Notice, like we said, the base of the cube that's on top and the base of the pyramid do not get counted. So what do we subtract? Good, so we're going to drop out one base from the cube and one base from the pyramid. So if I were to consider what my pure surface area is here, I'm going to find the area of the base once. Then I'm going to find the perimeter of the base times the height, and plus the perimeter of the base times my slant height. Okay, now what's nice is I've already been given all the information. My slant height is a 5, so there's L. The base of my pyramid is down here, or excuse me, my cube. And so I can calculate what B is real quick. B is going to be 3 times 3, so capital B is 9. My perimeter is going to be fairly straightforward because it's the distance around the base here, so 4 times 3, which is 12. And the height of the cube is going to be 3. So substituting in is not overly complicated here. So my surface area is going to be 9 plus P, which is 12, times my h, which is 3 feet, plus my perimeter again, which is 12 again, and my slant height, which is 5. 105 square feet. And there we go, a composite shape. So on number 13, we have two parts, the cone and the pyramid, or excuse me, cylinder. And when I take a gander at each of these, the cone's surface area is going to be pi r squared plus pi rl. And the cylinder is going to be 2 pi r squared plus 2 pi r h. Again, things that get eliminated here. I have a base that overlaps, so we get this new super equation, is that the surface area is going to be pi r squared plus 2 pi r h plus pi r l. So we need three things. We need h, the height of my cylinder, which is there. We need the slant height. And lastly, we need radius. So we're just going to plug those in and see what we get. Pi times 3 squared plus 2 pi 3 times 5.1 plus pi times 3 again times L, 8.4. So here we get 9 pi plus 30.6 pi plus 25.2 pi equals 64.8 pi, and that will give me approximately 203.6 square centimeters.